So hemolysis is happening. My recommendation, low pressure. If anything, if it stops pulling blood, pull, pause, pull, pause, pull, pause. What does a pause do? Let me show you. When I aspirate, it goes, ready? It closes, so if I hold it while it's closed, is it gonna help fill with blood? No, you've closed it, it's a valve. So you need to give the blood time to fill that vein back up. So pull, pause, wait for the blood to fill up, then pull a little bit, wait for it to fill back up, okay? So we're overcoming the pressure in the vein. We must pull with less pressure than what's in the vein. All right, so barotrauma, I used to call it cavitation. I was wrong. My friends have corrected me online aggressively and gently that it was barotrauma. Barotrauma is a technical term for when the cells and tissues being ripped apart because of the negative pressure. Watch what happens here. Now, before we go into the video, this is a problem I hear all of Latvia, all over the world, all over the Baltic region, all over the galaxy, all over, every nurse in the universe has this problem. When we draw blood and lab calls and says, hey, I'm so sorry, but the blood is hemolyzed. And what do? It's your fault. We blame it on the lab, but what we need to remember is that the hemolysis usually happens before it gets to the lab. When I was in the emergency room, my trainer said, if the blood tube, when you fill it up, it's clogged, it's no good. It must be liquid. I did not hear her say only some tubes must be liquid, right? So what did I do? When I saw the red, you guys have red colored tops? They're okay to clot, right? It's supposed to congeal, but I didn't hear that. So I was like, okay, good, and I send it. That's the problem. So when we drop it, okay, things like that, the trauma, a lot of what we're doing before it gets to lab is causing these hemolysis issues. So this is the definition of barotrauma. I think most problems are from when we're pulling, and I'll show you why.
Here's a good example of what's happening.
Look at the bubbles.
When we pull with two.
And I want you to tell me how big the bubbles are getting.
Blood is hemolyzing. So I'm going to suction that.
How big are the bubbles getting?
Plunge it with negative pressure. Look what happens to the bubbles.
Do you see how big those bubbles got? Now imagine a tiny, tiny, tiny cell, and we're doing that. What's happening to the blood cells? We are hemolyzing. How many of you, when you were drawing blood, you were like, ooh, I'm getting it, and then, no, oh, give me that blood. And you guys pull hard. I used to do it all the time because I was like, you're not gonna beat me, I'm stronger than you. I'm gonna get that blood. And it came little by little, and I was like, yes, I'm getting it. Have you ever noticed when you draw blood with the syringe, sometimes there's bubbles coming through? Did you ever notice that? Central line, right? Yeah, it happens. That's called barotrauma and maybe cavitation. So what we're doing is we're pulling with so much negative pressure that the gases are forming by themselves. That's 100% going to be hemolyzed. If you see bubbles, it's not leaking, it's something else. All right, so when we do this, we have to be careful because these cells are gonna break. When we stretch these, is this red blood cell any good? It's bad, it's hemolyzed. So be careful how hard you're pulling that syringe. Be gentle as possible. All right, so average normal pressure, master students, homeostasis, what is that? We went beyond homeostasis. Homeostasis is what is normal inside of the body or what the body's functioning with. If the blood functions at 2.3, what are we doing when we pull it out of the blood to 1? Atmosphere is 1. 1 atmosphere. Or less, depending on how deep you are on the water. So if that blood tube